the 13th century by an Italian named Leonardo Pisano, commonly known as Leonardo Fibonacci. Leonardo is considered to be one of the defining mathematicians of his century, having written a seminal text, Liber Abaci, which translates to the Book of Calculation, which can be credited with the Western world's transition from the Roman numeral system to the Hindu-Arabic system we use today. The Fibonacci sequence was first formally published in Liber Abaci alongside a thought experiment about rabbit breeding as a way of informally demonstrating the recursive sequence, although it should be noted that it was not Leonardo himself that first identified the sequence. It was first thought to have been identified by mathematicians in India sometime during the 6th century. Following its introduction to the Western world, it was over 5 centuries before the sequence was dubbed the Fibonacci sequence by mathematician Eduard Lucas as a tribute to Leonardo's influence on modern mathematics. Over the course of history, many mathematicians have worked to identify the unique qualities of the sequence, none of which Fibonacci himself identified.
The Fibonacci sequence form can be denoted as the two previous numbers added together to give the current one. This can be observed in the following sequence, where fn is equal to fn minus 1 plus fn minus 2, where fn is the term number, fn minus 1 is the previous term, and fn minus 2 is the term before that. When the sequence is expanded, it will look like 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so forth, as you can see. Now, the golden rectangle can be split into a series of boxes in which the side lengths are successful Fibonacci numbers, e.g. a 1 by 1, 2 by 2, 3 by 3, 5 by 5, and so forth. Now, each square will form a spiral when the arc of each square is connected to each corner, as seen. Now, these can be seen all over nature in examples such as snail shells, goat horns, and waves.
The Fibonacci numbers have quite a few applications in nature. However, I'd like to talk about an application in computer science, known as the Fibonacci search. And the basic idea is, in an ordered set of numbers, we're looking for a specific number, and we want to find an efficient way to find that number. So over here, we have a set of totally random numbers. Yet again, the only requirement is that they're in order. And the top numbers here are the index of that number. So 2 corresponds to the second number, 6 corresponds to the 6th number. And we need to choose a Fibonacci number that is the smallest, that is bigger than the length of our set. So the length of our set here is 11. So the smallest Fibonacci number, bigger than 11, is the 7th Fibonacci number, 13. And what we do is we decide a number we want to find. And let's say we want to find 93. We take our first Fibonacci number and we check position 13. Now, we don't have a position 13 number, so we go to the next highest one, which is 11. And we go, is 311 bigger than 93? And it is. So we cross it out and we go to our next Fibonacci number. Now we're on number 8. So we go over to 8 here and we go, is 143 bigger than 93? It is. And because this set is ordered, we can now cross out 9 and 10 because it's bigger than 143. We now go down to our next Fibonacci number, 5. We check position 5 here and we ask, is 74 bigger than 93? And no, it is not. So we cross out 74, and because all the numbers here are smaller than 74, we can cross out these numbers as well. Now we cross out the 5th Fibonacci number. And now, on our 4th Fibonacci number, we have to go to position 3. But what's happened is because we've deleted these previous numbers, this number here is actually position 1, and this number here is actually position 2, because the set has shrunk. And because 3 is higher than the amount we have, we cross that out, and we move on to our next Fibonacci number. Now our next Fibonacci number is 2, so we go to position 2 here, and we ask, is 108 bigger than 93? And it is, so we cross it out, and all the numbers above it, which happen to already be crossed out. We move on to our second Fibonacci number. We check position 1, and it is 93. And we have found our number.